Hello, students. Today we're going to talk about a fundamental concept in mathematics, which is the concept of solving. It's important to understand solving on a deep level because a lot of what we do in Algebra 2 and in calculus and in other math classes revolves around being able to solve. And in my experience, when I've asked students to solve, or when I ask students what a solution is, the responses that they give are not very good. They don't know what a solution is. A lot of times students will just say a solution is an answer. And then when I ask them what that means, they don't know. And then when I ask students to solve, a lot of times students think that solving is following a specific set of steps. And that's not really the case either. Even though there are certain techniques that have been established to solve, those techniques are not all of solving. And solving is a much broader and more interesting topic than just following certain steps. So anyway, let's talk about solving. So solving is finding a missing piece that makes sense in a situation, a missing piece of information usually. And in math, a lot of times we solve equations, which means there's a missing value, a missing number that we want to figure out what that number was or is, so that the equation can work. So on the most basic level, something like this, x plus 4 equals 8. What this is saying is a number plus 4 is equal to 8. And then when you're solving it, what you're actually doing is you're figuring out what that number could have been. And we can actually figure this out just by thinking about our addition facts. If you know that 4 plus 4 is 8, then you know that x can be 4. So that is kind of a very fast way to solve this problem. I know that in school, what they will teach sometimes is they'll teach that you can subtract 4 from both sides of the equation, and that also gives you 4. This is a valid way. This is an algebraic way of solving. However, doing this without understanding the first method leads to, it starts to give students into a habit of thinking that solving is just a set of steps and a set of processes. And that's what we want to avoid. We want to maintain our understanding that solving makes sense. And it makes sense not just in a math way, but it makes sense to our everyday brains that think about things. So x plus 4 equals 8. This gives us a very simple place to start. We can also do something like this, right? 2x equals 10, very sort of basic equation. This is saying 2 times a number equals 10. If you know your multiplication facts, you know that 2 times 5 is 10, so x has to be 5. Notice how I'm solving it just by using what I know. I'm not having to do any steps. It's just, oh, I know that 2 times 5 is 10, so that means x must have been 5. Some people, when they teach solving, they don't teach that, and instead they just teach, oh, you need to divide both sides by 2, and 10 divided by 2 is 5. Again, you get the same answer, but one way is very just procedural, and you don't have to be thinking too much, and one way is more about having it make sense. In both of these cases, the solution is the number that makes it true, right? So if x was anything except a 4, it wouldn't be true that you could add 4 and get 8. Like if this was a 3, 3 plus 4 doesn't equal 8. So 3 is not a solution. If this was like a 6, 2 times 6 is 12, not 10. So that wouldn't have been a solution. And that's the idea of solving. Now, equations get more complicated than this. For example, we can have an equation that has multiple steps, something like this. Let's make this into an 8. Okay. So whenever we have an equation that has multiple steps, it becomes important to understand, either mentally or you can write it down, the order that these happen in. And this is where the order of operations comes in. And some of you might know that as PEMDAS or GEMDAS or whatever. The important thing is you know the order. So for instance, any number that would go here would first add 3 and then multiply by 2 in that order. So we can use this information to understand what different parts represent in this equation. For instance, I know that if I start with a number and then I add 3 and then I multiply by 2, I'm going to get 8. And what that tells me is once I choose my number and I add 3, okay, everything in the yellow, once it's all solved, once it's simplified, I'll get 2, and that should be a 4, right? This yellow should be a 4. That way I get 2 times 4, which is 8. So that tells me x plus 2 should be 4. And if that's, or x plus 3 should be 4, excuse me. And that tells me that x, I can now use my math facts. That tells me x has to be 1. Right? So if x is 1, then x plus 3 is 4, and 2 times x plus 3 is 8. So if you can think of that also up here, a 1 plus 3 equals 4 times 2 is 8. And so x equals 1 is a solution because when x is 1, the equation is true. So we want to be thinking about, whenever we're solving, we want to be thinking about what number makes an equation true. We want to be thinking about sections of an equation if the equation is more complicated and if it has multiple operations going on. We want to think about them in a specific order. And then we want to think about after any given operation or between operations, what numbers am I landing on that is ultimately going to get me to 8. So here I started with the 1 and then I added 3 to get 4 and then I multiplied 2 to get 8. So there's this process, there's this progression of going through the operations. And just to see this really sort of complicated in one last example, we can do something like this. Okay. So this has a lot of operations and it equals 7. And we can, for instance, pick a number and that number we'll add 1 to it and then we'll multiply it by 3. Then we'll add 5 to it and then we'll divide by 2 and that's going to give us 7. So knowing the order in which that happens, I know that in order to divide by 2 to get 7, that means that everything here, all of this, should equal 14 because 14 divided by 2 equals 7. So I know that's the case. Okay. In this one now, in the order is that the 5 gets added last. So that means right before I add the 5, all of this should equal 9. Because then I'll have 9 plus 5 and that'll be 14. So that tells me that equals 9. Here, I pick a number, I add 1 to it, and then I multiply by 3. That's going to equal 9. So since I had to multiply by 3 to get 9, that means whenever I picked a number and added 1, this should have also been 3. That way I would have gotten 3 times 3 equals 9. And then if that's true, then x has to be 2. Think about how whenever we solved this, it was more of a process where we were just understanding what different sections of the equation had to be in order for it to make sense. Notice how we didn't just multiply both sides by 2, subtract both sides, subtract 5 from both sides, divide both sides by 3. That can get very mechanical and it can rob the problem of the actual sense making that is valuable to do with these kinds of problems. So from now on, whenever you solve, think about what it is you're finding. Think about how it makes sense. Think about how each step is connected to the next step, not by a math operation, not by a math, like a mathematical step in the sense of addition or multiplication or something, but it's connected to the next step because it makes sense. I'm just saying things that make sense based on what I know before, right? If I know this equation is true, then I know this equation is true. If I know this is true, then that means this had to be 9. If I know that's 9, that means this had to be 3. Okay, and it's just by making sense. So this idea of solving is the key to building your understanding of different solving techniques.